Okay, this is a 40-minute sessions. And we have here Dietrich, David, and Thomas, who will introduce the transactional outbox pattern and exploring its design in both the CAP Java and the Node.js stacks. And they will also have a demo and showcasing both implementations. So stage is yours now. Good luck with the screen sharing.
So, hi, yeah, we want to talk about the outbox, to be more precisely about the transactional outbox, and what do we want to achieve with that? So,
Блять, умри, сука, умри.
Okay. I cannot switch. I cannot switch. Yeah.
It's still showing?
Okay. Okay. Yeah, okay, now. So what we want to achieve with the outbox. So the outbox solves these three challenges. First, the resilience. You don't want to be blocked in your business request if you have any remote services that are temporarily not available. But you want to achieve that the remote request may be done a little bit later without blocking the business request. So this is the one challenge. The second one, of course, the transactional guarantee. I'm thinking about messaging. You don't want to be, you don't want to emit any business created event until the business partner is not committed to the database. And the last, of course, if you have a long-running operations within your business request, you maybe want to decouple them from the main request in order to achieve faster response time. So we use actually the common outbox pattern. So the main challenge is to serialize the events into persistable events. This could be a challenge because you have also to save some request context for that, and then you can store it with the business transaction, so that then the business section is committed, and asynchronous outbox collector can run, collect the events, and try to perform them. If the event could be successfully performed, then the event is removed from the outbox. Otherwise, it's removed back with incrementation of an attempt count. And if the max attempt count is maybe reached, then you can put it maybe in a dead letter queue. So if you configure in CAP the outbox, we inject into your application model our database schema for the outbox, so that we can put, as you can see here, some additional information for us and that we use. And with that, I would hand over to David to show you a short demo in Node.
So thank you, Dietrich. Now first I have to fight. Sorry about that. So everybody can see my terminal. Here I'm comfortable. And this needs to go away. Okay, perfect. Okay, so I have here a very simple CAP application. You don't see anything because I didn't open a file. And the only thing you need to know is that I have a dummy entity, a dummy service, nothing fancy. And I have here this remote service. And I don't want to use our messaging service or any other service. I just want to use a custom implementation because I want to mock an external service, because this is also about error handling and that things can sometimes go wrong. And I want to simulate this. So I have here my custom implementation. And it's a class which extends CDS service. That's how you define a custom CDS service. And it's very easy. I just say that whenever this external service gets the event dummy created, it starts processing the dummy created event. It sleeps for a second, and every second request will fail. The first one succeeds, the second one will fail. And then when it's done, I log it. So really super simple. Now in my service implementation, whenever a dummy instance is created, I connect to my remote service and emit this dummy created event, which then triggers the handler, which you just saw. And then I call my next handler, meaning I create the dummy entity on my database. So I can run this application with CDS watch, and I can spawn also a terminal. So let me just create a dummy instance. And you can see in the log, I get my post request. Dummy created is being processed, and it's done because the first request succeeds. But now we simulate that something happens in the remote system. Because whenever you await something, as a rule of thumb, it can go wrong because you are communicated with another system. So let me put that a bit more up so you can also see my terminal properly. Okay. So now I create another one, and as I said before, now the request should fail. And you can see we get an error message, something went wrong in the remote system, which is completely fine. And in this case, all the states are consistent because I haven't created anything in my database. The remote system call was also not succeeding. So both states are in sync, so to say. So far, so good. That is because this one here gets emitted first, and then only then, if nothing fails here, I proceed with the next. Now let's simulate a database error, right? So let's just throw new error. Oops, my DB made a mistake. Let's try it again. And now we have a problem. So I get my post request. I'm processing my dummy created event. It's done. So the remote system was changed. The state was changed. But now when I try to do something with my own database, it fails. And I get an error. But the remote system state was already changed. And that's not something you want to have. Now, for you to know a bit more what's happening under the hood, I can also add SQL logs. So now let me show you one little trick. We can enable the so-called outbox. So in my package.json, I say this shall have an outbox, and you can do this via configuration quite easily. You just say outbox true. Okay. What it does effectively is that when this emit is executed, it will not directly emit to the remote system. Instead, it will just say, OK, I'm going to wait until everything is succeeded and only then emit to the remote system. So let's do it again. See this watch. I execute my request. And now you can see there is no processing of this remote event because it will first wait until the whole thing is succeeded, meaning the database operation starts. But I simulated this database error, so everything gets rolled back, and also the remote event doesn't get processed. So everything is still consistent. So far, so good. But if I remove the error again, the first request succeeds, so here's everything's fine. But in this case, now if the remote system has an error, then we also have a problem because now we first do something with our database where everything's fine, and then we process the dummy created event, but that one fails. So again, we have an inconsistent state. So we just switched the order, so we didn't achieve anything. So far, the outbox was not great because per default, without configuring the outbox properly, I would say, it's just an in-memory outbox. We just hold this information in memory, and if it fails, we don't even retry it because also the server could crash, for example. Now, let's enable the transactional outbox or the persistent outbox. So for this, you need to add the outbox section to the CDS requires section. You can set it to true. By default, this is the persistent outbox. And what it does now is when you call emit or send, then instead of performing the operation, we write it in the database table which we created, which Dietrich explained before. And only if the whole thing succeeds, then everything is committed, and we have transactional guarantees that either everything is committed in the database or everything is rolled back. So there's no invalid state. And once everything is committed, then only then we, in another transaction, try to process the table. And if something goes wrong, we just retry it after an exponential backoff. So let's try it now again. The first event succeeds, but let's look at the SQL statements, what's actually happening. So here's my HTTP request. I begin my insert into the Outbox messages table. That is basically corresponding to this line here. It does a database insert. In the same transaction, I do the actual insert of my dummy entity. And then I commit everything. So I have transactional safety, transactional boundary around both operations. They either fail together or they succeed together, but it will not be an invalid state. And only after I commit it, I process those messages in a separate transaction. And in this case, it was succeeding. But if I do this again now, and we know the second request will fail. So again, I insert it in the database table. I commit it. Now I process them. So I select them. I try to process the dummy created event, but you can see the emit failed. So what do? We just update the database table for this particular message and add 1 to the retry count. Commit it. Then we wait for some time, exponentially increasing, and do the same thing again until it succeeds. And once it succeeds, we delete it from the Outbox table. Now, instead of doing it programmatically, so you can remove this configuration here, you can also do it, instead of doing it per configuration, you can do it programmatically. You can say CDS outboxed of any service you have, and then it gets automatically outboxed. So you can also decide on a case-to-case basis if you want to outbox a certain operation or not. So if I do that again, the same thing happens. So it's kind of boring. So it's not an exactly once guarantee, because it can still happen that you write something in your Outbox table, you process it, the remote service succeeds, but then when you want to delete it from your Outbox table again, something happens with your application, it crashes, for example, then it's still in the Outbox. And then the next time it gets processed twice. But that's not a guarantee anybody can make, because we do not have distributed transactions, and we do not want to introduce distributed transactions. So that's the best we can have, and it's relatively, I would say, unlikely that if we select the data from the database and process it, that we can also delete it from the database. So a message being processed twice or more times is unlikely. And with that, I give back to Thomas.
Now I want to show you the architecture, the Java architecture of the Outbox. In Java, we use a CAP service for a representation of an Outbox. Each Outbox has its own asynchronous collector, and as you can see in the CDS configuration, you can create an arbitrary amount of Outboxes. So that has an advantage that if you want to parallelize your events via the Outbox, you can create your specific amount and distribute the events among the Outboxes. And how we can do that? We have also predefined, if you start the CAP stack with a configured Outbox, you get an unordered and ordered Outbox by default that you can use. Additionally, you can configure the Outboxes. And here you can see this is the common CAP API. You have an event and you can emit it on a server, on a service. And if you have any handler registered for this event, you can provide the custom implementation of this event. And like in the Node stack, we provide also on the Outbox the generic API that you can outbox an arbitrarily CAP service and make it asynchronous. This is like what is showed in the lower image. We get a wrapper around the common service and emit all the events via the outbox generically. And as you can see, it's just only one line. You can outbox, and if you want to go back to the synchronous variant, you can use the unboxed API method. So the most widely used CAP service is the CQN service. And you can, of course, use the generic API to outbox this service, but it makes no sense to use maybe the select methods of the CQN service. And for that reason, for the convenience, to keep your code cleaner, we provide an asynchronous variant of the CQN service, which is restricted to only asynchronous methods. And you can easily, like I showed in this example below, just with one line, you can transform your CQN service into these asynchronous async CQN service and use it throughout your application in a really clean, type-safe way. The error handling is the next challenge. For the Outbox, we do not have any APIs, but we can use the common CAP API to achieve that. So we have on an event context the proceed method, which invokes the next handler registered for the next handler registered for this event in the handler chain. And here's a small example for audit logging. You can register a custom handler for all the audit log events, and you do it in an early phase in a handler order annotation. And with that, you can intercept all the audit log events and put them, the proceed method of the context, into the try-catch block, so that if you invoke the default implementation of their audit log handler, you can catch the error and inspect. And if you decide this error will never be solved, so you can maybe suppress this error, and the collector will remove the entry from the outbox. If not, you can rethrow the error, and the outbox will try it sometime later again. And finally, what we introduced, in some use cases, you don't want to have an order of your events. So by default, all outboxes call the events in the order in that you submit the events. And this is, of course, is done on costs of performance. And in some use cases, you don't need the order. You can switch it off by this order flag, and you will achieve that you can parallelize the events even on among the application instances if you scale your application horizontally. And in order to understand it, I showed how we do it. We read in chunks the events from the outbox, and we lock the chunks on the database layer, so that no other collector is able to read the chunk. And if you are running in an order collector, then all the chunks are read sequentially. And if the order flag is switched off, then we can use an arbitrary approach to read the chunks. So we can do it randomized, or we can try and try the next if fail. And with that, the order is lost, but we can achieve higher performance, a higher throughput in a scale, in a horizontal scale of the application. And with that, I would hand over to Thomas, show you.
Yeah, thank you. So the demo that I'm going to show is more or less similar to the one of David, because of the fact that the Java language is not as dynamic as JavaScript. It took us some brain power. And so, okay, now share. And you should see my IDE now. Okay, so yeah, for this demo, I'm defining my own custom Outbox instance in the application YAML file. I call it custom Outbox. And what I want to do is that I outbox a custom CAP Java service. In order to show you that such a CAP Java service doesn't need to know anything about the Outbox, you just implement it, develop it, and then you can outbox it. So for this, I'm defining an interface, my custom service, which extends the service interface provided by CAP Java. I have a service name and also an API method that is called person created, which receives two string parameters, name and last name. Then I also need my custom event context, which is being used in order to emit an event that then is getting handled in order to execute some logic. This is also an interface that must be annotated with the event name annotation provided by CAP Java. And that annotation receives the event name, which I define as constant. This interface needs to extend the event context interface also provided by CAP Java. And the interface provides a static method in order to create an instance and then getters and setters for a name and the last name. Both are strings. It's worth to mention here that those values of such an event need to be serializable and deserializable to and from JSON such that it can be written to the database. Of course, now we also need to have an implementation. This is being done in the class myCustomServiceImpo. It extends the service delegator class, also provided by CAP Java. And that class provides a default implementation for many other methods that a service need to provide. For our example, we can keep the default implementations, and hence our code is quite slim. And also, we need to implement my custom service interface. This class is annotated with a Spring annotation component such that it is getting instantiated upon service startup. In the constructor, I'm just calling the constructor of the service delegator class with a service name. And I define and I implement the API method from my custom service interface, which simply creates an instance of my custom event context, sets the name and the last name, and then emits this event context. And in this emit, the magic happens if the service is outboxed. Corresponding entry is being written into the database if the transaction is committed. If it is not outboxed, the logic will be executed right away. And the logic is defined in an on handler, which you can see in line 21 in the method handle person create. It receives an instance of my custom event context and just logs the data that is available in that context. Now, as Dietrich already said, the purpose of such a transactional outbox, and of course, David also mentioned it, is to decouple logic in order to make sure that still some kind of transaction or transactional behavior is fulfilled. So for this demo, I defined a service in CDS that provides an action, create person, which receives a name, a last name, both are strings, and a flag whether the outbox shall be used in its logic. I also have a database model that uses our Outbox model for the database. And we have a person entity that has two fields, name and last name, both strings, and they must not be null. In the corresponding handler for that action, we receive, first of all, the persistence service such that we can access the database, meaning writing data to the database. Then we receive an instance of my custom service and also an instance of my custom outbox. I cache those, and when it comes to my custom service instance, I cache an outboxed version of the service using the outbox service that is being injected. In my action, I'm first of all having a look whether my custom service shall be called outboxed or not. If it is called, if it shall be not outboxed, I get an unboxed version of the service again. And it is worth to mention as well that this whole mechanism is thread safe. That means you do not need to worry about parallel threads in your application, whether you are using the outbox or not outboxed service, it's working. So then we call my custom service with the name and the last name that we got passed, and then I create the person record in the database. Now, of course, we only want to have that this person created of my custom service is being called as long as the person record is created successfully. And for that, I defined some requests. Before of that, let me quickly show you the outboxes in the developers dashboard that Dietrich presented in the keynote. As you can see, we have here our custom outbox that I defined in the application YAML file, and then the two default outboxes that are automatically created by CAP Java, one ordered and the other one unordered. And none of those outboxes have entries so far. Now let's come to the requests that I just mentioned. If you remember the model, both the name and the last name must be non-null. So that means, for example, when I call the action with null values and I use the custom service directly, meaning not outboxed, then we have the problem that, as you can see here in the log, that I'm calling my custom service directly. Event is being emitted, and the logic is also being executed directly. Then the person entity shall be created in the database, which fails since the name and the last name both are null. And hence the transaction that is being opened in the action implementation is rolling back. Now, what happens if we still send invalid values, but we use the Outbox custom service? Let's have a look at that. As you can see, we still are calling my custom service, but now outboxed. We then store the corresponding outbox entry in the database. Then we are creating the person record with invalid values. Again, a exception occurs, which means that the transaction is being rolled back. And our logic in my custom service is not being executed. We can switch to the developer dashboard, and as you can see, no entry is available. And we can also do the positive case. That means we call the action with valid values and use the outboxed version of our custom implementation. In this case, it's the same. That means an outbox entry is stored in the database. We are creating our person record in the database. And since this succeeded and the transaction is committed, this is the trigger for the custom outbox to process all the entries that are available. So it reads them and publishes the message, the outbox entry to my custom service instance, and the implementation is called. And the data is logged. If we now have a look at the developer dashboard, we can see that suddenly a history entry appears here. And this is the entry for the last request. And we can see that the data that we sent to the action is present here in the data that was stored in the database. Okay, so I think we're a little bit ahead of time. And yeah, feel free to ask questions.
I have two questions. The first one being what services are required on BTP at deploy time so that this outbox can actually send something? And the second question would be, is the retry mechanism on the database layer or on the application layer?
Well, you need to have a database such that the outbox entries can be stored somewhere if you use the persistent outbox. The outbox itself is a CAP service that is running within your microservice. And the retry mechanism is also implemented in the outbox, meaning the outbox consists basically of two classes. One is more or less the interface to the stakeholder application or to our implementation itself, and then we're having a collector that is being triggered as soon as an entry is being written to the database, or it triggers itself frequently in order to check whether there are still outbox entries available in the database. For example, if you restart the service before every entry has been processed, and you want to make sure that that all the entries are processed before a new one is being written to the database.
Have any other? Go.
The same question. So do I just need to define in the requirement outbox and then I can use the outbox, or is there some service I need to onboard in my sub account?
No.
Huh?
All you need to have in your microservice, at least for the Java version. I mean, it's regarding the CAP Node.js stack. David also showed it. all you need to have is to include the Outbox model into your database model. And as soon as this is present, the default persistent outboxes are brought up and can be used.
Okay. And one of the nice things was that you can kind of filter out the errors that you don't want to be reprocessed. Is it also useful for remote services, and especially how the reprocessing works there if I have something like principal propagation set up for the end user?
Yeah, of course, it is very useful when you use remote services. And regarding the error handler, you also receive the exception. So that means you can analyze what really happened. And then you can, skip the entry right away if you get to know, okay, this error won't be fixed in the future, or you can write it somewhere else in a administrator's cockpit such that it is not being lost. But that depends on your application.
But how would it have the user context for reprocessing if I have something like principal propagation? For reprocessing.
You can, yeah.
I would have to use kind of like a technical user in that case, because if I have something like in API management in between, and I'm propagating the principal from the CAP application to my backend system. So in that case, for reprocessing, I would have to have something like a technical user and then pass the audit log sort of to the backend that, okay, this person maybe made the transaction. Okay.
Exactly.
That's it. That's it.
Yeah.
Time is over. Thank you, Thomas, Dietrich, David.